Hi Tyler.
Hi Dr. Godis.
Welcome to the periodic table for the pre-class video on solutions and ionic compounds in water. So what you're going to be learning about is that when you dissolve a compound in water, what it does depends on what kind of a compound it is. Is it an ionic compound or a molecular compound? And so if you dissolve a molecular compound like sugar in water, what happens, what's going on when sugar dissolves in water?
Well, sugar won't dissociate into ions. So it's like that little six-membered ring, and it's just going to stay together, right? And so you might get individual molecules of sugar kind of cruising around in water, but you're not going to get those broken up into atoms or ions.
Right. So molecular compounds, since they're not composed of ions, they're one molecular unit. In the solid, they're all kind of packed together, layered together. And when they dissolve, molecules pop off, and they get surrounded by a cage of water molecules. Now, ionic compounds are different, because ionic lattices, it's not just a bunch of molecules that are kind of stacked together in the solid. It's ions, cation and anion, alternating in these lattices. And so what happens when those dissolve?
So when those dissolve, that's a little different. They actually dissolve into their individual ions. And so they'll actually break apart from each other.
Okay, so what you're saying is that when something like sodium chloride dissolves in solution, the sodium ions go and float off on their own, and then the chloride ions float off on their own. And so if you're going to do chemistry on sodium chloride in aqueous solution, how is something going to react with both the sodium ions and the chloride ions?
Well, it wouldn't. It would react with one or the other. And so let's say it reacts with the sodium ions. We'd call the chloride ions spectator ions because they're just watching the action and they're not really even taking part in it. But if it were to react with a molecular unit, for instance, like glucose, right? It would react with the molecule, the entire molecule, and not just one part of it.
Right. And so it makes chemistry of ionic compounds in water, it can seem a little confusing at first, but it's actually a little simpler in the end, because the ionic compound breaks apart into the individual ions, and then usually only one of the ions participates in a reaction. The other ion is a spectator. And if you can get the idea of a spectator ion and start to identify spectator ions, it'll really simplify a lot of solution chemistry. So what kind of ions tend to be spectator ions? Do you recall?
Well, usually, sodium's usually a spectator ion,
Yep.
just because chloride ions tend to be more reactive.
Yeah, sodium tends to be a spectator ion, potassium.
Mm-hmm.
Rarely are they going to be involved in a particular reaction. And with enough experience, you start to get a feel for what are spectator ions that you can probably ignore, and what are the things that you really need to focus on. So make sure you keep track of charges, because what makes an ionic compound ionic are the charges.
Mm-hmm.
What makes a molecular compound molecular is the fact that it's not charged, it's not ionic. So the charges are really important. And I think that's enough information to get you started on the activities for today. Good luck.